Alright. The sound you're hearing is the rod hitting the mirror. And I can time it to see what the RPM is. Here is the rotor. Here is a huge coil. It is 4,000 feet. 4,000 feet of wire. And it cost me $40 at Altex. Here is the insane connections. I connected all the wires in series. This is made of flat ribbon cable. And I didn't even have to wind this. This already came like this from this thing. Here is the specifications. Okay. Here is the old coil. Here's the new coil. This new coil is 3 times longer than this. And I'm only using 0.01 amps. 0.01 amps or 10 milliamps. 10 milliamps. Or less. Somewhere between 5 and 10 milliamps. I am using only 16 batteries that are AA batteries. I'm only using about 0.2 watts. We'll see by checking the voltage right now. So, pull this out so it stops. Okay, so I don't have to reconnect the multimeter. This is just what it says. I'll have to put it in the right position. Now it says 22 volts. So, we have 22 volts times up to, somewhere between 5 and 15 milliamps. So let's say 10 milliamps times 22 volts is 0.22 watts. 0.22 watts. 0.22 watts. As you can see, magnet is a small part of the coil. This coil weighs several pounds, and as I said before, it's 4,000 feet long. This coil is only 1,300 feet long. Every charge of the leading battery coming from this will go through the entire coil. So this coil is like 3 of these. This is every charge goes 3 times as further. So it's like going through 3 of these. So, and it's combined into one coil, so it's even more efficient. And I'm getting all this power out of a tiny 0.02 amps. 0.02 or 20 milliamps. This is a RMS multimeter, meaning a true RMS multimeter. It measures the true root mean square of current. It also measures the true root mean square of voltage, meaning that it's not just like any digital multimeter. It actually measures RMS. Now I wish I could show you the more detailed milliamps, but my fuse on this port over here broke. So I'll have to get a new fuse. I don't think it's that expensive, but this one still works because it accepts higher current. This is a 20 amp setting, so it shows up to 20 amps. And this is 0.02 amps, which is a 10,000th of that, or a 1,000th of that, I think. See, 10, 100, yeah, 1,000th of the maximum allowable current going into here. So this has more torque and more speed than this, and it only uses, I don't know, 1/5 of the current. I was wondering if I could just encapsulate this magnet inside like a wheel, and I could turn this thing upside down and use it as one of the wheels for, say, a go-kart or something. I'm just wondering, this coil already alone is $40. To have 4 of them, you would have to have $160 for that, and batteries and stuff. But I still wonder if I could power a go-kart on less than 1 watt. Because if I increase the size of the coil, every time I've done that, every time, I get more power. And I use less power. It's weird. Because I got my amp turns. So, even if I got volts and amps, okay, but my amp turns determine how strong this is, alright, and I'm not using that much amps, so I'm draining the battery more slowly, but I got my voltage, so I can spin it fast, so I can get through all the turns. It still means I'm draining the battery more slowly, because, I mean, fact is, no matter how many batteries I have connected together, if I'm drawing less amps, it's gonna take longer to discharge and stop working. And could I run a go-kart on 0.01 amps? Can I? I think I can. I think I can. I mean, I just have to scale this up, get a better magnet, or who knows what. Who knows what. I mean, they can power wheels for kids, like Jeeps and whatever, they run on like less than 100 watts. Okay? Why do we need big batteries to run these Jeeps when we can use AA batteries? If we can run it on 0.01 amps, heck, I mean, it would run for a very long time. How come, why should we be satisfied with go-karts that only run for 15 minutes? We should have go-karts that run for a week. A week. Autonomous vehicles, or whatever. Or whatever, you know? Why can't we? Why can't we? Why can't we just keep our charges working for us as long as possible and not wasting it and dumping it back into unemployment right here, the back of the battery where it can't do anything for us? We should keep it inside the coil and keep it moving. As long as we have the voltage to do it, we can keep it moving. And we can get it to do work for us. If we decide to make the charge unemployed, it's going to be right here. It's going to be in the battery. It's useless once it reaches the end of the battery. So, we'll see.